Meant.
Okay, and thanks, Joshua. Hello, everyone. So I'm just trying to share my slide. Okay, it says sharing is okay. Finally shares. Okay, try it again.
Okay. Do you have permission to share?
I do.
Okay.
Just that it seems to be. It looks like Zoom is rugging.
Oh, Zoom.
Unfortunately.
Zoom.
Okay, so I have a couple of key. Not sure which one is the. It's not giving me it's not giving me a display of what exactly I'm looking at, but let me see if this is it. You gotta be
Okay.
kidding me. Okay, so I have to reshare Zoom here. All right, so I think this should fix it. Okay, so I have to leave the meeting and join back, unfortunately.
Oh, all right. No problem. Welcome, guys. I hope you're enjoying this session so far. This is the last virtual session. I can see some familiar faces. I can see Dean, and that's because Dean actually has a profile picture. If not, I think I recognize Caleb, the name. I'm not sure. Anyways, welcome. I just want to reconnect. You'll be back soon. Oh, and if by chance, guys, you guys can retweet the post on Twitter so that people can know we've started. Just tweet and say the virtual session with Africa build event is started. Or perhaps I could share the tweets here in the chats in case you can't find it. Let me do that. Um, yes.
Is my screen visible?
Wait. Oh, yes, I can see it now. Yes, I can see it.
Hallelujah. Okay.
Glory.
Okay, so share my video so you guys can see me. Okay, so hello everyone. My name is Favour. Today I'm gonna be taking everyone through a guide. Just beginning a session on how to, building a Telegram smart contract event relayer service on Arbitrum. Yeah, that was a mouthful. I even had to breathe in a bit. Yeah, but it's gonna be fun, and I'm really happy and honored to be, uh, to be invited to give the session to you. And yeah, so let's just get into it. All right, so who am I? Right, so my name is Favour Ohunoha. I'm self-taught and I've been coding for over 12 years. I've also been working in Web3 for the past 4 years. I currently work as a developer relations engineer at Swing Finance. And if you're not sure what Swing Finance is, we are a digital asset liquidity routing service. So if you're looking to bridge your assets from one chain to another chain, we provide APIs, SDKs to help you build that integrate cross-chain capabilities into your decentralized applications, right? So that's a bit on Swing Finance. I also create content on social media with over 58K followers across my social media handles. Yeah, and also I'm a guy who wants to fly jet one day. Not sure how that will happen, but hopefully one day. Yeah. So yeah, so what are smart contract events? So let me just give you a little rundown on what this is about, right? So the app we're building essentially is just going to be able to listen to events on a smart contract, which we are going to deploy. And when an event is emitted on that from that smart contract, we're going to have what's called a relayer service that is basically going to be listening for events on that smart contract. And once an event is fired, our event relayer is going to push that data to Telegram API. We're going to also be working with Telegram, and Telegram API is free, by the way. So yeah, just to mention that I'm going to be integrating Telegram to be able to send messages. We're actually going to build Telegram bots, right? So once the relayer service, which is listening for the events, fires, it's gonna send the data over to Telegram, and then Telegram is gonna forward that message to whosoever is to view that message. Right. So yeah, so we're gonna be, so before we get in, since smart contract events are the center of everything, I'm just gonna be defining to you what a smart contract event is. So smart contract events are special login mechanisms used in blockchain platforms such as Arbitrum to emit specific messages or data when a particular function is executed, right? So the way they work is that they are actually embedded in functions that are executed. So say you're transferring funds. Let me say Joshua is sending funds to Daniel, for instance. What happens behind the scenes is that an event is actually emitted, right? Even though you don't see it, right? This is just native blockchain transfers, right? On the EVM. What happens is that when you open your MetaMask wallet and then you decide to send, let me say, it to your friend or anyone, behind the scenes, an event is actually being logged, right? It's being logged and stored on the block that has been mined. So you can actually confirm that if you make a transaction, you can click on that transaction. You can actually see the events that were emitted for that transaction that you did, right? So what these events do is that they allow off-chain systems like decentralized applications or dApps, and users to listen for and react to specific changes in a contract state or behavior without constantly querying the blockchain, right? So without this feature, right, what it would mean is that you would have to somehow find a way to query to query the activity that has happened on the blockchain. Say we had like a mapping where we were storing all transactions that were going on. If there wasn't a way to actually emit events from the smart contracts, you would have to keep querying that list of transactions to find the one you're looking for. And this can be really bad, right? So this can be really bad if smart contract events doesn't exist. So what it would mean is that if you had a mapping with over 2,000 records and you wanted to just you wanted to be able to read the data, find a particular transaction that happened, let me say 2 days ago, right? Just to forward a notification to the person who sent it and the person who received, the money, the two parties involved in the transaction, you would have to literally look through that mapping to be able to find that particular record, right? So yeah, so that's what smart contracts events about. So then what is a smart contract relayer service? What are smart contract relayer services? So a smart contract event, a smart contract event relayer service is a specialized service that listens for specific events emitted by smart contracts on the blockchain, right? So they are just normal service. They can even be an API service, right? They could be a background service. If you've done Windows, if you messed around with Windows background services and you know how to write one, it could even be that, right? As long as it can connect to the blockchain, then it can be really a service. That's if it's fits the criteria, right? So they're just constantly listening for events on that particular deploy smart contract, right? So so as I said, but they listen to relay information to off-chain systems or other blockchain network. These services play an essential role in bridging, on-chain blockchain and off-chain, that's external data ecosystems, by helping to automate responses to blockchain events and integrate blockchain activities with traditional systems or cross-chain operations, right? So that was quite a mouthful, but as we go on, I'm gonna be, referencing back to this, right? So it's basically just this section, the second section I just read just basically talks about what the use cases for smart contract relayer services, right? So it's mentioned bridging on chain data. So bridges utilize this a lot, right? Centralized exchanges also utilize this a lot. Later I'll get into how they actually utilize this, right? So we're actually building this on Arbitrum, right? So in case you don't know what Arbitrum is a layer 2 scaling solution for the Ethereum blockchain, right? So in case you're not familiar with layer 2 scaling solutions, there's a bunch of tools and solutions that the community have come up with, built to be able to scale the Ethereum blockchain. And as we know, the Ethereum blockchain, which is like the layer 1, is quite slow, it's expensive. Um, it's very hard to scale, right? And it's generally just creates a bad user experience across the board, right? So that's why we have a lot of layer 2 scaling solutions for Ethereum, and Arbitrum is just one of them, right? So Arbitrum aims to improve speed and reduce the cost of transactions while maintaining Ethereum security and decentralization, right? So it's actually built with optimistic rollups, which processes transaction off-chain and then periodically pulls data to Ethereum to ensure security and correctness. Right, so that's just a bit on Arbitrum. So as I mentioned, why we need Arbitrum, because it's way faster, way cheaper, and highly scalable than Ethereum, right? So yeah, so let's look at some use cases for an event relay services, and who's using them, right? So probably this could be the parts where you sort of start to connect the dots on what event relay services are and why they are so powerful, right? So one use case for an event relay service is centralized exchange wallet monitoring. An example of dApps that are using this is Binance and Accru. I don't know if anyone here has tried use Accru before. Really, really, really cool app. You can easily on-ramp and off-ramp using it. But I'm sure everyone here is quite familiar with Binance, right? So in case you don't know how Binance works, Binance is centralized, right? What happens is that when you deposit money into it, every other operation is internal, right? It's via Web2 means, essentially. It uses databases. Once you've deposited your funds into Binance, then everything else is just like a database call to move funds around and everything, right? So, but how Binance manages that, even though they give you a real wallet, is that when you create a Binance account and you get, say, an Arbitrum wallet, for instance, right, and you deposit money into that Arbitrum wallet, what's actually going to happen is that there's a smart contract. There's a smart contract attached to a wallet that was deployed using a wallet that is constantly monitoring your wallet, right? Your Arbitrum wallet that you got on Binance. So what happens is that when money gets into that Arbitrum wallet, which belongs to you, there is a relay service that is constantly, listening for events. Is that relay service is going to, alert the Binance main system or whatever they're calling it, and because the private keys of your wallet is managed by Binance, they can easily, move the funds from that wallet into their smart contract that is managing all the wallets, right? So that's how come, you never really see what's going on in your Binance wallet, even when you view it on app on Etherscan or AppScan or whatever. There's a bunch of relay services that are just listening for events on your wallet, and what it and are able to relay information to the Binance main service, and be able to move and credit your Binance wallet, right? So user also does the same thing, right? So the second use case for event relay services is to monitor liquidity pool events such as token swaps, staking, and yield farming, right? If you're into DeFi, you probably might have heard of KeFi or DeFi Llama, right? So when you go on DeFi Llama, I think DeFi Llama is even more popular right now. When you go on their site, you see a lot of data just coming in and out. So what they're doing is that they're probably integrated into third-party services that are using event relay services, right? So they are constantly listening on events happening in the smart contracts that are listed on their platforms, the NFTs and the tokens, the trending tokens that are listed on their sites. They are constantly listening to the events being emitted out of those smart contracts, and then taking the data and aggregating it and giving it back to you, right? So another use case for event relay services is cross-chain bridging services, right? So if you've ever used a bridge before, like Across Bridge or D-Bridge or Paraswap, right? This actually is the technology powering bridges, right? So what happens is that, imagine you wanted to bridge USDC on Arbitrum to USDC on Ethereum. What's actually going on is that there's one relay service on Arbitrum and another on Ethereum. When you actually interact with the bridge, what happens is that the bridge is going to begin the transaction and emit an event. Once the bridge has confirmed that the funds have been moved from your wallet into the bridge's smart contracts, the bridge is going to emit an event. Now, the event that is emitted will be captured by the event relay service, and that event relay service will be connected to multiple blockchains, and it's going to be connected to the destination blockchain, which you're moving your tokens to, which is going to be Ethereum, right? So the event relay picks that event from Arbitrum and then creates a transaction on the Ethereum side, right? And another use case for this is notifications. And one good example of this is Onboard Wallet. I don't know if anyone has tried Onboard Wallet, but if you've tried Onboard Wallet before, you would notice that the moment you make a transaction, you receive you're gonna receive a Telegram message, which is quite fun, which is quite cool. And this actually is gonna be like the basis for what we're gonna be building today. I'm gonna be showing you how to build something similar to what Onboard Wallet has, right? So brace yourself, this is gonna be fun. So yeah, moving on, okay, sorry, it's live typo. How does it work? Yeah. So a smart contract event is emitted on Arbitrum. The event is stored on the block in which the transaction was mined. The relay service will be listening for events on that smart contract, and then the relay service will forward the data or message to an external service, say Telegram API, for example, for processing. So I think I did touch on this a bit on the last slide, right? So just come on, sorry. So just continue on this. I just have a small chart here, so explain to you how this works, right? So we have.
Yeah, sorry. We have a question. Can you
Okay.
check the chat?
because I'm, where is the chat? Sorry, I can't quite see it. Okay. Are we using Arbitrum stylus library? No, I'm not using that. Okay. All right. So yeah, let me continuing. So I'm just gonna give you a chat.
I'm sorry, I didn't get it because of the network.
Yeah,
What did you say?
I'm like, oh
Are
no,
we going to use it or not?
no. We're not using that here. I didn't use that in my example. Does that answer your question? Can you hear me?
Yeah, thank you. Sorry,
Okay.
network is.
Oh, don't worry, don't worry. It's totally fine, man. Okay, so I'm continuing. So how does it work? So this, sorry, I couldn't fit all in the other slides, so I just had to break it up a bit. So for what we're going to be building, we're going to have two users, right? So user A, he wants to send funds, right? He sends funds into the smart contract. An event is emitted, right? This event that is emitted then gets stored on the EVM event logs layer. So what's happening is that whenever you interact with a smart contract, and that interaction with the smart contract is changing the state of that smart contract, essentially it's considered a transaction, right? So it does a transaction on a blockchain doesn't necessarily mean that you're just moving funds from one wallet to another wallet, right? It could be that you are just updating the state or just updating a variable. Say there was a say you had a variable called hello and you wanted to append word to it or just change it to something else totally different. If you did that, if you called a function, that function updated updated that variable in the smart contract, that's actually considered a transaction, right? Now, what happens is that whenever you perform a transaction, you're executing a function on on the EVM, on an EVM. What happens is that if any event is emitted in that function, the EVM is gonna log that event and store the message inside it on the block, right? On the same block in which that transaction was mined. So after the transaction has been confirmed and mined, if there are any events that were associated with that transaction, they're going to be stored on the EVM event logs layer, right? So what then happens is that once the events has been stored, it's gonna be read by our off-chain relay service, right? And our off-chain relay service is gonna forward this data to the Telegram API, which the Telegram API would then forward that to user B. I think I have another question. So it's going to be done. Yeah, so we have a question. Would the interaction with the Telegram API be done by the smart contract or the dApp? So it's actually going to be done by the off-chain relay service, by the event relay service, right? So the event relay service is listening for transactions, it's listening for events on the smart contracts. And once that is done, once it gets any form of transaction, once it finds any event, it's going to read the data that is being passed through the events and then forward that data to the Telegram API, right? So we'll be getting into it in a couple of minutes. All right, so carrying on, just tools and setup. So this is just what tool setup. This basically what we're using, right? We're gonna be using Solidity and hard hats for smart contract development. React on the front end for the relay service. We're gonna be using Node.js, and we're also gonna be using the Telegram API, right? So we're actually gonna be using the Telegram bots API, right? So yeah. So it looks like did I okay, it looks like I skipped pages. Yeah, so this was actually supposed to come later, but that's fine. Okay, so for the next step of the session, I'm gonna be taking you through a code walkthrough of uh, the example that I've built. it's something I'm calling Trooper, right? So how it works is that it basically works like what I just showed you here. A user sends funds to a smart contract. Whilst he's sending the fund, he specifies the user address he's forwarding it to. And then our off-chain relay service is gonna read the event that's emitted from the smart contract when send funds is called, forward that to the Telegram API, and then forward it to the user who is associated with that wallet address to which the funds is going to. Right. So let me share my screen. Give me just a minute. Okay, so I probably should start with this rather, right? So we're actually going to be building a Telegram bot, right? Something called Trooper bot. So what happens with Telegram is that you have to create a Telegram bot, and then users have to subscribe to that Telegram bot. So what happens is that when a user subscribes to the Telegram bot, their Telegram ID is actually shared with whatever service that is running the Telegram bot. In this case, that will be our relay service, right? So our relay service will be communicating directly with Telegram via this Telegram bot, right? So I've built this Telegram bot called Trooper bot, and actually building a Telegram bot was surprisingly very easy. You just have to message. I believe it's called the bot's father. I believe my screen is visible, by the way, just to confirm.
Yep.
Can anyone?
Yeah,
Okay,
yeah.
great. So you just have to message the bot father. You click on start and then just follow the prompt to create a bot. Very quite easy. I had no idea, but it's actually really easy to create a Telegram bot. All right, so yeah, so let's get back to TrooperBot. So what TrooperBot is gonna do is that with TrooperBot, you just have to subscribe to it, and then whenever someone sends you funds via the DApp we're gonna build, you get a notification essentially, right? So I'm just gonna give you a short example of how it works, and then we're gonna get into the code walkthrough. Right, so you have to start by saying you have to interact with the bot. So say you're a new user, you're just finding about it for the first time, you've been told to subscribe to the bots. You just come here and type in /start, and then the bots will respond to you. Over here, you can see it says you are already registered with Arbitrum address. So it actually, tells me my address is registered. If you want to register with a different address, please send it now, right? So I'm already registered. So this is the message that I'm getting. But once I'm done with the code walkthrough, if there's still time, I'm gonna redeploy the smart contracts with everybody watching, and then we can, start afresh. Yeah. Okay. So yeah, so this is how it's going to work. Let me share the platform, the DApp that's have been built with it. Just give me a minute. Sorry. Okay, so sharing right now. Okay, hopefully it's visible now. Is my screen visible?
Yeah, yeah.
Okay, so I'm just gonna try this out to see if it works. Because I did have a few bugs when I was trying it out. Okay, so confirm, yes. So it tells me I'm not registered. It's supposed to update. Okay. All right. So it's a bit slow right now. For some reason, it takes a while to query the blockchain. Let me see if I redo this. Okay, you know what? I'm just going to take you guys through the code and the code walkthrough. Then when we're done, we can actually come back and look at the DApp. Then I can sort of figure out why it takes a while, but sometimes it just comes, which is just weird. Okay, so let me take you guys through the code. Then after that, we'll get back to actually doing creating the example. Once I'm taking you through the code, I'll probably just deploy a new smart contract so that you guys see how that works out. So sharing the code right now. Okay.
We
Okay,
are
so
only seeing the DApp. We are not seeing the code.
do you see it now?
We are seeing the DApp, actually, not the code. I don't know if you are sharing the
Oh,
team,
it
but we
says,
are
yeah,
seeing the DApp.
sorry, it says my screen sharing is, okay, it says my screen sharing is paused. Let me share it again and see if that works. Is my screen visible now? Is it visible now? Okay, great.
Yeah, yeah.
Yeah, sorry for the hassle. Okay, so there's going to be three main parts of our DApp, right? So the first part is the smart contract. The second is the relay service, which is written in Node.js. Can you zoom out, please? Zoom out or zoom in? Just to confirm, is everything, is my code visible? Someone is saying I should zoom out a bit. Okay, I don't hear anything.
It's kind of jamming.
It's kind of what?
It's
Like, it's not
visible.
kind of, it's visible, but it's not clear. It's kind of jamming.
Okay,
I
is it
think
clear?
it's different network, but it's visible.
Okay. All right. So I guess everyone can see it, but some people can see it, but I'll just move on. Okay, so okay, so someone says visible, so fine. So as I said, we're gonna have there's gonna be three parts to the DApp that we are building, right? So there's gonna be the smart contract, right? Which we are calling Trooper. So in case you forgot, I mentioned earlier, Trooper is gonna be Trooper is just a DApp that allows people to register. You can register and then you can send funds to other registered users, right? So I'm just going to take you through it. So here we have cost per SMS. So you can also, one functionality that smart contract, this Trooper smart contract lets you do is to send, text message, right? So every text message you send, every message you send actually costs you, right? So I just put this in there for practical reasons. It's cost 0.0005 ether, right? So we have a user struct here that's going to store all our registered users and their Telegram chat ID. This is really important because without this Telegram chat ID, we can't send messages to anyone. Our bots cannot send a message to anybody, right? Then we're gonna have what we call a troop of troops, right? So sort of like how we have Twitter and Twitter, and then you have to tweet. On Trooper, you can send a troop, right? So In the struct for the troop, we have an ID, also have sender, a receiver, and the message you are sending, right? So we have some mappings here just to manage our users, troops, and the Telegram chat IDs. So we have this here. Okay, someone has his hands up. And please ask your question.
Hello, can you hear me, please?
Yeah, I can hear you.
So for the Telegram chat ID, is it for individual chat ID or the person that is making the
so individual chat IDs? Yeah. So like
so
I said,
if you have to send me a message, you will need my chat ID.
no, not exactly. So before you can even register, you have to interact with the bot first. You have to subscribe to it. So that was what I was trying to demonstrate. When you press slash, when you give a backslash and then you press start, so what actually happens is that it's gonna ask you for your wallet address. And when you enter your wallet address, it's gonna give you your Telegram chat ID, right? Which you then use to register. Okay, so this Telegram chat ID, the only way for us to get it from a user is for them to first interact with our Telegram bots. Okay, you have another question?
No, it's okay. I'm trying to remove the hand.
Okay, all right. Okay, so as I said, we have three mappings here. Want to manage our users, our troops, and the Telegram chat ID to address. So this is just why we need this over here, is because we want to be able to check with the Telegram chat ID and see if an address already exists, right? And here we have the most important part of our smart contract, right, which are the events. These events is what our relay service is going to be listening for. We have a send troop when a troop is sent. We have a user registered, right? And we also have send funds, right? So for the sake of time, I will not be touching on the send troop. So I'm just gonna be focusing on these two, the user registered and the send funds. So we have a function here that is executed when a user registers. So when a user goes on our DApp, let's say our DApp is hosted on www.troop.com or whatever. When a user goes to troop.com and then registers, so there's going to be a register button. I'm sure you guys saw that you are not registered. Click to register. So what's going to happen is that the DApp is going to request for the Telegram ID you got when you interacted with the Telegram bots. You're going to input that and it's going to register you using your Telegram ID, right? So as you can see here, is this just basically, adds the user to the user's mapping, basically just registering them. And then it emits a user registered event. The reason why I'm emitting it is because I want to be able to send the user a message when he registers, right? That congratulations, you are now registered on Trooper app. You get it. So we have to emit this event, right? Or else our relay service will not be able to know that a user has registered, right? So by the way, I just have to mention that these mappings are private, right? Because if somebody actually gets your Telegram chat ID, they can spam the living air out of you, right? If they have a bot account or something. So it's essential that we keep that private, and then we have functions just to retrieve those private data. And we're actually making sure that every single time the person trying to access it is actually the owner, right? It's actually the owner of that Telegram ID. So we're checking that the message or sender is equal to the user address takes the parameter that has a parameter right here, making sure that that user address matches the message or sender, to make sure that they are the right one accessing that data, right? So the rest of these are just, like I mentioned, the rest of these functions are just here just because we made this private, right? We create because they're private, we have to add more functions and check that the person actually the wallet trying to access, the Telegram chat ID or whatever data is actually the person that registered in the first place, right? And because because we have this function here, send funds. What send funds actually doing is that it's moving funds from one user, from one wallet to another wallet, right? And because it's involves sending native tokens, we have to attach this payable we have to attach this payable flag here to tell Solidity that this function expects funds to be sent to it, right? And there's also this non-reentrant. So if you're wondering what that is, just to avoid reentrancy attacks. How reentrancy attacks work is that when this function right here, receiver.transfer, it's actually calling, well, think about it this way behind the scenes, it's actually calling an external contract. It's actually calling an external service. Just think about it that way. It's actually calling an external smart contract. So what happens is that the smart contract will actually not wait for this to get executed, right? So it takes a while because it's doing that over the network. So what happens is that if this function doesn't resolve in time, an attacker can just keep invoking the function and transferring more funds. Can keep invoking the function and transferring more funds to themselves. It's sort of like, I mean, for those in the house who heard about this Betway saga, where somebody was trying to withdraw, like, let me say 5,000 naira, and he kept tapping it. He tapped it like 100 times, and within the span of 2 minutes, he had gotten, like, I don't know, 1 million naira or something. Yeah, so basically that's what this prevents, the non-reentrance. It prevents that kind of attack, a reentrance attack, right? So after we're done, after our function is almost done executing, transferring the funds, what's going to happen is that we're going to emit a send funds event, right? And what this essentially is doing is that it's going to emit the event. The event is going to get logged and stored in the block, and then our relay service is going to be able to pick it up, right? So yes, so that's it for our smart contract walkthrough. I think someone said, will I share this on GitHub? Yeah, I'm going to share this on GitHub right after the call. I'm also going to put it in the Web3 Africa community so everyone can see it. So yeah,
Please.
so
Sure, please.
yeah.
Yeah, sorry, the non-reentrance modifier, please, can you show it?
Yeah, there's it. There's it.
I mean,
Can
the
you see
code.
it?
Yeah, I've seen where you use it, but where the code.
I'm sorry, I'm confused. You mean where I'm declaring it?
Yeah, where you're declaring it.
Oh yeah, so it's declared over here. So over here I'm importing
Okay,
it.
from
Open
oh,
Zeppelin.
okay.
Okay. So yeah, I'm using Open Zeppelin contracts, by the way. All right, so great. All right, so the next part of our DAP I'm gonna go through is gonna be relay service, which is actually which I've actually made an API service, right? So in this service, we're gonna be communicating with the blockchain. We're also going to be communicating with Telegram, the Telegram bot API. So I'm using this package called Node Telegram bot API, which sort of makes life simple when dealing with the Telegram API. So over here, I've got contract API, right? Because we need this to be able to map the function to be able to for ETS to be able to understand our smart contracts. Over here, I also have these are just like a smart contract address, provider URL. So I'm using Alchemy for this. So for the RPC, I'm using Alchemy, and then the Telegram bot token. So when you interact with that that bot I told you about, Telegram bot father, and you create a Telegram bot, they're going to give you a Telegram bot token. So that token is what we're going to be using to control the bots, basically send messages to the users on our DApp, right? So for this ENVs over here, I actually have them out here. So when I push it, I'm going to include this. So if you want to also build, expand on this, all you have to do is just basically get your private key, Telegram bot token, the smart contract address, Arbitrum, the Arbitrum minutes RPC from Alchemy or from Favour, whatever provider you use, right? So yeah, so basically what in our API we we have quite a few functions, yeah, quite a lot. But what is most important is this part right here, right? So you see our contract right here. We're actually initializing it over here using ethers. So we're initializing a contract object here, passing the contract address and contract ABI. So once you deploy the smart contract, you just have to put the smart contract in your ENV, right? So this is actually the most important part of our relay as service, right? So over here, we are listening to 3 events: send troop, which I said we won't really look at. We're also listening to user registered, and we're also listening to send funds, right? So when any of these events over here are called, our relay service is just basically going to pick it up, right? So it's going to pick it up, and then it's going to, based on what type of event it was, it's just going to respond accordingly. So we have a question. Yes, Telegram works in real time. Let's look at it. Yeah. Okay, so I see someone say, I see someone saying solidity. I'm a bit lost with the context. Okay, probably it's fine. Okay. So yeah, so in the case of user registered, what we're doing is that we're just sending our user a message saying new user registered, send them the address, also forward to them their Telegram chat ID, right? So we have this function here called send Telegram message. And what it's doing is that it's actually going into the contract and calling this get user Telegram chat ID, right? So what this is doing is that it's mapping the address to the chat ID, just essentially checking to see if that user is already registered, right? So if the user is registered, and this function is called, it will return that user's chat ID to our relay, right? And what our relay service can then do on registered is that it can then just send the message, straight to the person. So every single time we call this function, we are passing the address, and this line of code right here is just basically mapping the address to the chat ID, fetching the chat ID using the user's address, the wallet address, right? So so this bot.onText is actually coming from our Telegram bots, our Node Telegram bots API SDK, which I said helps deal with the Telegram API, makes life easier for you. So what we've got here, you see, we have on start for instance. When you go on the Telegram bot and then you put in /start, it's just basically going to get your Telegram ID, check if you're registered. If you are registered, it's going to tell you that you're already registered. If not, it's going to ask you for your Arbitrum address, right? And every single time you send a message to our bot, it's just assuming that you are sending an address, right? So just to make it simple, I didn't want to make it so complex to add more commands, but this /start over here is actually a command. So you're issuing a command. It's checking to see that the message actually starts with start, and then it can then run this block of code over here. But if it's just a message that's basically anything else, it's just going to assume that you're sending an address, and it will actually return to you your chat ID. So as you can see over here, I think I saw a message. So I'm sorry, I got. Can you drop a link for the Telegram bot documentation? Yes, I can do that probably after. But if anyone here knows the link, so please drop it for Dean. Okay, all right. So yeah, so as I was saying, this hook over here or callback function, what it's basically doing is that it's just listening for whenever a user drops a message. We're always going to assume that the user is dropping their wallet address, right? So if the message comes through, we're just going to check to see if the person is already registered. If the person is already registered, we're going to tell them that you're already registered. If not, then we're going to tell them that we're going to send them their Telegram chat ID, which they are going to use to register on our DApp. Okay, so we have another message. Okay, yeah, good. Someone shared it. All right, so yeah, so that's the walkthrough of our relay service. So essentially, these two parts are actually the most important. The final piece of everything is actually the front end, which is built using React and Vite. It's gonna be quite a lot on time if I'm gonna go through this, but I'll just give a quick run through. So just similar to our earlier service, our front end also needs to be able to understand the function that is going to be executing via ethers, right? We have a lot of hooks over here just to manage states, to check if a user is connected, user is registered, to store a user address and Telegram chat ID, receiver address, and we basically have a lot more functions just focused towards managing the user's address, right? So checking to see that a user switch wallets, right? So for all of this, I'm going to share it on GitHub. I'm just going to push it to GitHub if anyone wants to look through it, right? So I'm actually going to be starting afresh. What I'm going to do is that I'm going to deploy the smart contracts. I'm going to take you through the steps. Okay, someone a question before I continue. Okay, all right. Okay, so that wasn't a question. So please, if you have a question, I'm only going to respond to those who have their hands up. And Amin, you have a question?
Yeah. So
Okay.
I want to confirm that we're on the same page. So um deploying a smart contract is on the blockchain, while the deploying this relayer service will be on the server side, right?
The server side, yes. It will basically be on the
Okay.
server side. Yes.
Thanks for the thanks
Yes.
for the
We are
clarification.
all on the same page. Okay. All right. So yeah. So for deploying the smart contract, I'm actually using Hard Hats, which quite easy to use, helps you manage, helps you build smart contracts faster. So inside a contract, I'm sorry, I just have to drink water quite quickly. Just give me a minute. Okay, can you hear me? Am I audible? Okay, good. Okay, so I'm using Hard Hats, right? For writing the smart contracts and deploying the smart contracts, right? So Hard Hat is just a tool that aids you in your smart contract development. It gives you a lot of libraries for it gives a lot of libraries for handling smart contracts related operations like verifying your smart contract and a whole lot of other cool stuff. So yeah, so in this project, I have two functions here. One to deploy, the smart contract. That's the smart contract that we have written right here, and another to verify the smart contract. So by verifying the smart contract, we can be able to view it on AppScan, right? So yeah, I'm gonna be deploying the smart contract right now. So to deploy the smart contract in my package JSON, I've actually put together a lot of scripts to help with this. The I'm gonna be deploying on the mainnet, but if you prefer, once you get your hands on the code, you can also deploy it on testnet. It works the same way, right? So the first thing I'm gonna do is I'm just gonna deploy the smart contract to mainnet on Arbitrum. So to do that, I'm gonna run npm run deploy main. And you see a message that is deploying, it's deploying Trooper. Yeah, so once it's deployed, you get this Trooper deployed, and then it actually gives you the contract address. But before I go check this out on Abiscan, I'm going to verify it first so that we can take a look at the insides of the smart contract. Right, so to do that, we're going to run npm run verify main, which is going to, sorry. So before continuing, we have to actually update the.
Sorry, can you zoom in, please?
Can I zoom in? Is it visible now? Is it visible?
Oh yeah, it's fine now.
It's fine now. Okay, sorry about that. Okay, so we have to update our env, put in our smart contract address over there. So since this is being recorded, I will just have to pause the sharing just to update my env file. Okay, so now that is done. So what I did was just update the smart contract. All I did was just update the smart contract property, env property in my env.env file. Right. So now once I've done that, I can then verify it by running npm run verify main. Okay, so okay, interesting. It looks like when I ran it the first time, it actually verified the smart contract. So I'm just gonna go on Abiscan right now just to check out the contract. So I'll be sharing that right now. Okay, so share this rather. Okay, just to confirm my screen is visible. Okay. Good. So now we've deployed our smart contract and we can verify it by checking it out on Abiscan, right? So you can see this was deployed 2 minutes ago, and we can actually read through the smart contract code. But what we're most interested in is the to read and write to the smart contract, right? So I just want to see if sorry, just a minute. Okay, good. I was just trying to hide this Zoom meeting controls was blocking what I was doing a bit. Okay, so this hasn't updated. All right. So what I'm gonna be doing is that I'm gonna be interacting with the smart contracts via Abiscan. Unfortunately, it looks like the dApp I was building is a bit broken. This would have been a bit more faster. But I mean, no worries. We can still do it via Abiscan, right? So the flow for how our dApp is going to work is that a user first has to go to our Telegram bot, to interact with it, right? So once they interact with it, it's going to ask them for their wallet address. Once they enter their wallet address, it returns to them their Telegram chat ID. Once they get their chat ID, then they can come here and call this register function, right? So what I'm going to do, just probably to make my life easier here, is that I am going to share I'm gonna share my entire screen so that everyone can see. So new share, I'm gonna share the entire desktop. Okay, so now I can easily switch between this. Okay, so what I'll do next is that I will sorry. Okay, good. So I'm actually gonna run our API. Our API, which is holding our relay as service. So npm run start API. Good. So now our relay as service is running and it is actively listening for events on deployed our new smart contract, right? Our newly deployed smart contract. So what that means is that once I get back to Telegram, for instance, let me clear chat history and I click on start, then it tells you welcome to register. Please send your Arbitrum address. What I will then do is I will go to my MetaMask, and for this I want to use I actually have two accounts. I have first account, second account. So I'll use my first account for this, right? So I'm gonna copy this and then I am going to send this to the bot. So I'm actually doing this on my banner account. So I'm gonna be creating a second account right after this. But when I'm doing that, I'm actually gonna stop sharing because I don't want the Telegram ID of my main account being leaked out there. So hope you understand. Okay, so now I get this message saying that your Arbitrum address has been received. To complete registration, please call the register function on the smart contract with this Telegram ID, right? So I'm gonna take my Telegram ID and I'm gonna connect wallet on the same I'm gonna connect to the same wallet I shared to the Telegram bot, right? So what I'm going to do is I'm just gonna call connect wallet here. And it's gonna ask me to, so I'm gonna use MetaMask. Okay, so it's connected now, great. So what I'm gonna do is I'm gonna call register and I'm gonna send the Telegram chat ID. So I'm gonna click on write. And then it's gonna ask me to confirm, right? So I'm just gonna confirm. What is, okay, reject all 5 transactions. What is that? Okay, so I'm gonna click on this again. Okay, looks like there's something weird going on here. So let me reject all of this. Why is it? Okay, so there seems to be a problem with Abiscan. I encountered this earlier on, so let me just refresh and try it again. I still somehow have 6 transactions. Come, just a minute. Okay, so I think this is what is causing it. All right, let me cancel this. Reject 5 transactions, reject all. Can you guys see my MetaMask, by the way? Is it visible?
Yes, we can.
Okay, great. Okay, so let me try this again. I don't know why that was happening. Okay, it seems to be connected now again. So let me try it one more time. Hopefully that does not happen. And it is still happening. Okay, so I'm trying to, my apologies, I'm just trying to figure out why this is happening. It seems that Abiscan is sending multiple transactions to my wallet. Okay, you know what, let me close my browser and get back and just try it again. Please, apologies, just a minute.
Hello, can anyone hear me? I can't hear.
Yeah,
Oh yeah, I'm
I
still
was about
here.
to ask the same question.
Yeah, can you hear me now? Okay, coming. So
Yeah.
some weird reason, I don't know what's going on actually, but it seems that Abiscan keeps sending multiple transactions to my wallet when I try to write, which is very weird. Let me try close. Maybe there might be another tab trying to access. Still happening. Very interesting. Okay, so probably.
There is issue with this Abiscan Explorer testing.
What is it?
I think there is issue with it.
What is it?
I think there is issue with this tester. Like I've even tried it.
Yeah. Oh, really? Okay. I mean, it's quite weird. I don't know why it's happening.
Yeah, it's receiving excess gas fee.
Oh, okay. Yeah. Thanks for letting me know. I thought I was doing something wrong. Yeah. So I actually experienced it when I was testing this, but it went away. I don't understand. It's sending multiple transactions. So I actually tried looking for a different scanner on Arbitrum, but I couldn't find any that could execute smart contracts. So in the light that there's no other tool I can use to test this. I might have to end it here unless I'm able to find the root cause of this. But I think as it stands, Scan is sending multiple transactions, high gas fees, which doesn't make sense. Okay. So I think probably what I could do to at least make it up to everybody is when this starts working again, I can actually record it. Basically just record the section, testing it, receiving the Telegram messages and everything, and just put that in the put that in the Discord community. I hope that makes it up to everyone. My apologies again. Okay, so with that said, I might have to end it here. It's rather unfortunate. I was really excited for this one, to show how everything just works. But it looks like we've got sorted. So that's everything for me. So thanks for joining. I hope you learned something. I'm gonna push this to GitHub. I'm gonna share it. I'm gonna share it and in the Web3 Africa community. For anyone who wants to actually take a look at it, can also try it. And basically, if you try it, you get it to work, please, send a screenshot of video, let everyone know that you actually got it to work. So yeah, with that said, thanks for attending and thanks for listening. So over to you. And John, is he still here? And so Joshua.
Yeah. All right. Hello, can everybody hear me?
Yeah, I can hear you.
All right. Thank you so much for the session. So I know there'll be questions to how people can get the resources and stuff like this. Would you share those with me or like in the other group after the call so that those I need to follow up? Yeah, and maybe the slide. I don't know. Yeah.
Yeah, I'll share it with you. I'll share it with you.
All right. I believe there are no further questions because I know that you gave some extensive period for questions. So thank you so much for being here with us to run this. We're really excited for what you learned. I hope you guys have gotten context because the hackathon is going to be intense. And I believe that you have an opportunity to still ask questions from Favour. He is on Twitter if you need to reach out to him. And Favour, can you paste the socials in the chat? Or where people can conveniently reach out to you that you prefer.
Okay.
So, yeah.
That right now.
All right. Okay, and that's it, guys. Thank you so much for coming around for this. This is the time where you start preparing yourself. The hackathon, the mini act is tomorrow. The event is tomorrow. Start preparing yourself. Start readying yourself. Start, getting ready to show up and learn and connect to people. And more importantly, hack. And that's it for today, guys. See you on the next one.
All right. Bye, guys. Thanks for having me.